Okay, so hi everyone, Senan this side, and in this video we are going to see how do we actually solve this convert 1D array a 2D array. So you are given a zero-based indexed one-dimensional array named as original and two integers m and n should be the size of the shape of this two-dimensional matrix. And what we have to do is recreate this 2D matrix using all the elements from this original. And now this is just explaining how do we actually place the elements. So take the first, there are two elements in the first row, take the first two elements, place them here, take the next two elements, place them below that. So and this is your 2D matrix. So it's quite straightforward. So what we have to do is return an m cross n 2D array according to the above procedure, or an empty 2D array if it is impossible. Okay, so the very first thing is, when do you know that if it is impossible or possible? You could see number of elements in this original is 4 and in this 2D matrix also, and similarly when it is 3 and the 2D matrix number of elements in the 2D matrix is also 3, there is a solution. But when the size of the original list does not match with the size of the matrix, we return an empty list. And this is what we are going to do. We are going to see that if m times n is equal to original dot size, the size of original, the length of original. So if these are the same, then that means we can actually have a 2D matrix, which would be a possible solution. Otherwise we just return an empty. And the next thing we need to understand is how to do the mapping of the elements. So given this 0th position in this original array, I need to figure out a mapping between 0 to 0, 0, 1 to 0, 1, 2 to 1, 0, and 3 to 1, 1. I need to figure out this map. So the question is basically asking you two things. First, check if it is possible or not. And the second one is, do you know how to do the mapping? And that is what we are going to do. So clearly, if the size are not matching of this original list and this 2D matrix, we return an empty list because there is nothing we could do, right? But if we don't execute this if statement, that means we have a solution that exists. So by this line, I know the existence of a solution. So I initialize with m rows and n columns, and I don't specify any values in that. So this would be storing some garbage values, which we are going to now update. Now what I'll do is I'll traverse through the original list from 1 to the size of original list, and what I do is I'll do the mapping. So from this we got this row comma column, right? So that is how this is the way we are going to do the mapping. So given I, when I divide I by number of columns, I get the row value, and if I take the modulo of I take I modulo n, that will give the number of columns or the column number of this particular L, right? Why this works? It's obvious, right? So if I is greater than n, let's say I is n, so that means, or I is equal to n even, so that means we have the first n elements in the first row itself. So now we have to start with the second. So that is why if I is n or n plus 1, the row value would be 1. That basically tells you that it's the second row. And doing the modulo operation would give the column number as always. So this is a classic way when you have to do a mapping from a single integer to a pair of integers, right? And this is used in a variety of problems. And even if you don't understand this, I'll go over this in this test case. But you could either, if you understand, that's good. If you don't, just take a pen and paper, try different matrices, draw different matrices, try to do the mapping, and you'll get the whole idea. Now when I have done the mapping from I to row comma column, I'll just update that value in this 2D matrix, and in the end I'll just return the answer. Before we do a dry run this code in this test case, what I'll say is to first understand the time and space complexity. So the space complexity is m times n, right? Because in the first case we would be having a solution and we have to have an m cross n matrix. So the space complexity is m times n, and the time complexity is what? Again, it's m times n, because we are going into this for loop, right? And we know that original dot size is equal to m times n if we reach this for loop. So this, although it's looking like a single for loop, it is m times n. This for loop will run for m times n times. So that's the solution. It's working, accepted. So let's discuss this test case. First of all, let's discuss. So original dot size is what in this? It's 2. And what is the size of the 2D matrix? It's 1. So 2 is not equal to 1. So in that case, we return the empty list. Yep, we executed this if statement. Otherwise, let's look at this from 0. And I know the row and column both are 2 in this case. So column is 2. So I'll take 0 and I'll say 0 by 2 is 0. So I know this value 1 would be placed in the 0th row of this 2D. Now 0, what I take 0 and I take the modulo operation with 2. So 0 modulo 2 would give me again 0. So I know it's in the first column. So I know it's in the 0th column, 0th row and the 0th column. So I know the value of 1 would be placed here, and that is what I'll be doing here. Again, for this 2, I is 1 and I by 2, which is 1 by 2, which will be 0. Why? Because we are storing that value into an integer, so a truncation would happen. So 1 by n is 0 in this case, so we know that value 0, value 2 is in the 0th row of this 2D matrix. Now I take this value 1, I take 1 modulo 2, and that should supposedly give me the column. So 1 modulo 2 is what? It's 1 itself, right? So I know this value 2 is in the 0th row and the first column, and so I place this 2 at this location. Similarly, this this location is the second location, so I is 2 for this, and I say 2 by 2 is what? 2 by 2 is 1, so that is basically giving me the row number of this integer in this 2D matrix. So I know this is in the first row, that means the bottom row, and then I'll do a modulo operation. So 2 modulo 2 would be 0, so I know it's in the first or the 0th column. So I know it's in the first row and the 0th column, so I place the value 3 here. And finally, for this 4, I'll say that 4 has I equal to 3, so 3 by 2 would give me 1. 3 by 2 is giving me 1. I know 3 by 2 is 1, so I know it's in the first row, but when I do the modulo operation 3 by 3 modulo 2, I'll get you 1. That means it's in the first column. So it's in the first row and first column, so that is why I place the value 4 at this position. In the end, I'll just return the answer and we are done with a dry run, and this will be working correctly. If you want, you can just try this out as well. Since there is a single row, we'll just place all the values as it is in the 2D map. So yep, that is the whole video. I know it's quite simple. The only thing you need to understand is when this is possible, and whenever it is possible, how do you do the mapping of a single integer to a pair of. So yep, that was the whole video. Thanks for watching. Time and space complexity is both m times n, and I'll see you in the next video.